Okay, can you guys see my iPad?
Yes.
Yeah.
Yeah. Okay, so let's start with question one. It doesn't. What's going on? Very weird. Okay, question one. So Terry loves yogurt. Okay. So Terry loves yogurt in the past. Oh, did I record? That's not recording. Oh, okay. I'll just cut it. Okay. So question one. So Terry loves yogurt. In the past, he has found himself spending too much money on yogurt. Last year, he set a weekly yogurt budget of $16 for himself. So budget equals to $16. A mental account. Okay. In other words, he will not spend more than $16 a week on yogurt. Also assume that the weekly budget does not carry over. For example, if Terry has $1 left over week one, Terry will not get to allocate $17 to yogurt on week two. Okay, so every week, I'm just like gonna draw something kind of like pictorial to represent. So you have $16 every week. And then you're not allowed to borrow or save for different period. Okay. So price of yogurt is 1. Was 1. I think this question it's like similar to what we have for midterm. Mental accounting. Okay. So Terry does not discount the future periods. Assume the price of yogurt is $1. In any given week, Terry gets Y utility. Y equals U from consuming yogurt, while Y is the number of yogurt. Number of yogurt. Okay. Okay. So, however, in a week that he eats yogurt with friends, Terry gets more utility from yogurt than usual. So if Terry is eating with a friend, so utility of friend equals to W square root of Y. Okay. And W is greater than 1. So it means that U of F is greater than U. Okay. That's a long question. Over the course of 4 weeks, how many units of yogurt will Terry purchase and consume? So we have 4 weeks. So we just sum up all the weeks. So 4, 0, xi. In this case would be just square root of y plus square root of y plus square root of y plus square root of y. What did I do? Like that. It should be. So how many yogurts, right? So weekly budget is $16. So it should be 16 plus 16 plus 16 plus 16. Am I crazy or is there a music? Okay. So so that's the units of yogurt, right? That's the total units of yogurt. What's the total lifetime utility he received, assuming he is alone? That will be sum of utility which equals the square root of y plus square root of y plus square root of y plus square root of y, which is square root of 16 plus square root of 16. That's it. Any question on A? No? Okay, should I keep going, or should you guys just ask me questions? I feel like I'm asking easy
Can you
questions.
keep going?
Okay.
I also have a question. So we have that utility and there's no betas because he doesn't discount the future, right?
Yeah.
Okay.
Okay, I should keep going. Okay. Now suppose in week 1, a local grocery store has a box of yogurts. So we're gonna have this tiny pictorial representation of our weekly budget. So week 1, so local grocery has box of yogurts that's given, which is 100 units. So 100 units of Y will be given on the first week for free. Over the course of the week, Harry consumes all the yogurts. Again, alone. What a lonely Terry. Okay, so what does Terry do what will Terry do at the end of the week with 16 that he has allocate to this week? So with this type of scenario, so her utility, Terry's utility function is equals to square root of y, right? And it resets every week. So if Terry has 100 packs of yogurts on the first week, so of course, Terry will consume 100 cup of yogurt plus $16. 16 units of yogurt because he has to spend it all because he cannot save and to the future period. Okay, so that's for I. So you just have to explain a little bit because number 1, it's mostly like short response. You just have to explain the reason why. Okay, for 2, if Terry did not set a weekly budget for himself, what would he do? So if Terry does not set a weekly budget, well, which is the mental accounting, then because the yogurt expires, right, at the end of the week. So in week 1, well,
I'm sorry, can you explain I again? So he has 100 and yeah, I'm confused about I.
huh?
Can you explain I again?
I?
Yeah.
Oh, I is just week 1 and week 2 and week 3 and week 4.
Oh no, I'm saying like the first part of B, I'm sorry.
Oh, this thing?
Yeah.
So in week 1, he was given 100 units of yogurt, right? But he has also in week 1 has $16. But because he has this mental accounting, he will spend all the $16 into yogurt. So in week 1, he will consume 116 units of yogurt, right? To maximize his utility. Because his utility resets every week. Not like utility reset, but his mental accounting resets.
Okay, so he wouldn't move the amount of yogurt between weeks?
He can't, right? It's in the here. So for example, I can't draw. I don't know why, but here. For example, if Terry has $1 left on week 1, Terry will not get to allocate $17 on week 2. So it means Terry cannot save.
Oh, I see. I guess I was just confused because I thought that if he is not spending any money on yogurts, then it's fine.
Think about this as Terry has this yogurt desire resets each week, right? So every week he has to consume yogurt, and it resets every week. The amount of yogurt that brings him happiness, it got resets. But in 2I, which is if Terry did not have the mental accounting. So if he does not have a mental accounting, his distribution will likely to be this. Like if you have 100 units, then Terry will evenly distribute it at $16 from week 1 to all 3 other weeks. That's 2I. If he does not have a mental account. If he does not reset, then that means that he can save in the future. So he can save this $16 and evenly distribute it to the next 3 weeks. So first week, his utility would be a U of W1, the square root of 100. U of week 2 equals to square root of 16 divided by 3. Some number. So all the rest of the week will be the same. It will be evenly distributed. And then you maximize each week. I mean, maximize like sum of all the week, which is 1 month of happiness together. That's E2.
And he can only move the $16.
You can't move this 100, right?
Oh, I see. Okay.
Because it expires in a week. That's why the
Mhm.
grocery store give it to Terry.
Okay. So he would just get an additional, I guess, 16 thirds per week 2, 3, and 4, right?
Yeah. Exactly. Okay. Any question on B?
This is suboptimal consumption, right? One of the examples of suboptimal consumption.
You can compare them, right? So if we compare like the consumption in a month, so for I it would be equals to square root of 116 plus square root of 16 plus square root of 16 plus square root of 16 in a month, like utility of month. But if you don't have a mental accounting, yours will be look like square root of 100 plus square root of 16 plus 16 divided by 3. 3 times that equals utility of month 2. Oh, I mean 2 is like without mental accounting. I mean you can do the calculation. I'm pretty sure that it's the first one, it's less than the second one.
Okay, thank you.
Yeah, because like the function looks like this, right? The more you consume, the less it gives. So like 100, 116, it's like this size of this, it's definitely gonna be less than 16, and then 16 plus 16 divided by 3. Like this portion into the utility. Does it make sense?
Yeah, makes sense.
You don't have to mathematically calculate it. Like this question, it's you can. You don't have to. It's mostly short response, asking for intuition. But you might have one on the exam. So just know how to do those. Okay, C. Now let's set aside the information introduced in part B. In other words, there's no box of yogurt. Now you have you have on week 3. Now you have a friend, Gina. Oh, unexpectedly arrive in town. So 2 of them have dinner. After dinner, Harry wants to have a yogurt, but he already spent entire weekly budget. Also assume Gina is unwilling to buy yogurt from him. Oh, interesting. Okay, so now we're in a scenario that is exactly about the suboptimal, like about this mental accounting, right? So if you already consume everything on week 3, so let's say like, okay, so for mental accounting, so let's u equals to mental accounting. So what's your happiness? Your happiness will be square root of 16, right? But if you happen to like borrow or somehow save a unit of yogurt, you will have square root of 15. So this is somehow you save, that will be plus W of square root of 1. No. What am I doing? This is a unit. Your utility is square root of all the units consumed in 1 week. So this should be plus. What am I doing? Let me see. Let me read the question already. Okay, this is kind of confusing. We can't apply that W to everything, so it should be something like 15 if you save one. But this one doesn't make any sense. Plus,
Wait, Andrew, I have a question.
yeah.
Where it says in the question that he already spent his entire weekly budget. So does that mean that if he spends it, that doesn't mean he's consuming it right away?
Like, because okay, so let's answer the question. I'm more digress. I didn't answer the question. So for I, what will Terry do in this scenario, right? So Terry will do nothing because he can't do anything. He has this mental account. He cannot overspend, right? So he will just have to deal with not eating any yogurt. And for 2, if Terry did not set a weekly budget for himself, what would he do? Right. So we don't need to solve this numerically. I was trying to like giving a numerical one, but it doesn't look too pretty. So if you did not set a weekly budget, what would you do? You would definitely borrow a unit from the future to consume now, right? Because whatever you have in the future is square root of 15, and then for the, well, let's say this is week 4. If you borrow 1 unit from week 4 and into week 3, your week 3 will become square root of 16 plus some W of some utility. It says square root of Y. I'm like a little bit sketchy on this thing. Like, why is it square root of y? So your utility it's w units of square root of y. And then w is a scalar. I don't know if Terry gets more utility in that one yogurt, or is it Terry getting more utility in the bulk of the weekly yogurt? That's a problem, right? Unless on week 3, his utility become W of 17 or W of 16. Compared to previously, just U3 previously equals to square root of 16. Am I reading something wrong?
Yeah, the question is a little confusing because it seems to imply retroactive utility improvement.
Yeah. If your friends eating with you in that week improves overall week utility, then it's definitely higher because W is always greater than 1, right? But if you are only improving on that unit, depends on the W, it might not be. Does it make sense? Yeah. I think he meant this in this case. Just improve overall weekly consumption of happiness of the yogurt. So it would be W of 17 or something. Or maybe it's just W16. The additional eating one with a friend would be just like a W scalar. Okay. Maybe this question, maybe ask for a little bit more clarification. Okay, that's for C2. So discuss how on D, discuss how mental accounting leads to suboptimal decision making in this problem. So if you prefer to eat with a friend at that week and you don't have the money to spend, the most optimal definitely is just like, borrow the money and then do it now. So you gain the most optimum utility. Optimum consumption. Yeah. So you just imagine scenario like this. You went out for a date and then somehow you spend all your wages. And then yeah, suddenly a date show up. And then because you don't have money, you can't go out for a date. And you would rather spend or like borrow some money from the future so you can enjoy this happiness or overall happiness. That's the suboptimal decision making. Similar to development economics, that a lot of times people don't have enough money to buy like sewing machine. Like if they have sewing machine, like they can improve their income or like overall like happiness or utility or like overall income or just like level of quality of life better if they can just borrow money from a bank But most of the times, like that facility doesn't exist, and they can't really borrow the money from their future self to sort of like starting a business or an investment. And somehow they just forever trap into this like poverty cycle because they don't have enough like capital to push themselves out of poverty. Does that make sense?
Yeah.
But that's more development economic. It's not really like mental accounting. That's more of restricted by the by the how do you say those? Yeah. I guess it's like by some I don't know, banks. Yeah. Okay. So that's the mental accounting part. And E, instead of a weekly budget, could Terry instead use some sort of commitment device to moderate his consumption of yogurt? Okay. So this is more open-ended question. It's like about commitment device. It's about like how can Terry sort of like improve his like, I guess, like we don't know what Terry do during the week. He could have just like consumed all the yogurts in day one, right? Monday. And he didn't like evenly distribute it out throughout the week. And then, or maybe he forgot to eat yogurts throughout the week and then he eat everything in the last day, right? Or somehow he just forgot and then his mental accounting resets and then he didn't get any happiness during that week, right? So like instead of having this mental accounting, maybe we can use some sort of a commitment device that it's more evenly distributed throughout the month instead of like resetting like weekly. Yeah, just think about like commitment device. Like, yogurt yogurt subscription, perhaps. Yeah, something like that. Does that make sense?
Would a contract work too?
Contract. Could you give me an example?
So, a contract that basically lets him swap out yogurts and what was the other suboptimal thing that he does? And lets him roll over his yogurt consumption each week.
Contract with who? With Terry's friend? It seems like Terry is a loner. He also like always eat yogurt by himself.
Yeah, I
Yeah, I
suppose
mean,
maybe there's a company that will do it with him.
right. Like,
Maybe has a subscription service for
yeah.
yogurt.
I think subscription service, like kind of like the, like every morning there's like one milk delivered to your door. Like of some sort, or like every week there's like bulk of like yogurt delivered to your door. I don't know. Because he's mental accounting like resets. Like for example, if I'm too busy this week, but somehow it resets the next week, I didn't have time to spend all my money on yogurt and have zero consumption of yogurt this week. So that's like very suboptimal, right? For like in terms of like in the perspective of a month, I will have zero, like square root of zero in this week. And next week I can only spend $16 again. Yeah. I don't know. Yeah, I think this is the open-ended question. It's just that you need to kind of like make enough like supportive evidence on how this could work as a commitment device to moderate the consumption. It could be a infinite, I don't know, like some kind of like really high-tech fridge that yogurt never expired. Something. I don't know. Yeah. Okay. That's for the fun question on A. Okay. Should we get on with Fear-Schmidt? Oh, yoga alarm? Yeah, that could work. Yoga alarm. Huh. So bizarre. Okay. Now let's move on to Fear-Schmidt. Because like the question one, it's I think last year we skipped this topic. Totally. We don't have to do a homework on it. So it's like, yeah. Okay, let's do Fear-Schmidt. I like Fear-Schmidt a little bit more. Okay, so let's talk about Fear-Schmidt. So what do we remember about Fear-Schmidt model?
Utility is determined by inequality inversion.
Okay. So it's a aversion to what?
Inequality. Both advantageous and disadvantageous inequality.
So utility equals to is of I and j equals to I minus a I max of xj minus xi 0 and minus beta I max xi minus xj, right? So this part is what? Let me just do this. So what's alpha stand for? Like this section of the utility function?
That's how much the individual hates income inequality, income inequality where they are below the other individual.
Okay. So it's aversion to others' fortune. So if you make more money than me, I'm gonna be in pain. Right. So xj is the other person and xi is myself. If you make more money than me, then my overall utility would be xi minus some alpha I of some number, right? I guess it's the difference between you and me, right? Yeah. So it's aversion for other people, others' fortune, and then part beta is aversion to others' pain. So if I see other people are suffering, and I'm gonna feel pain too. So if others are below me, I am gonna feel the pain and this utility. So this is all in my own words. You probably have like better way of remembering it, but this is just for me. So what happened? What happened if beta equals 0? And what happened if beta equals to -1 Yeah. And what happens if alpha it's equals to 0, and what if alpha equals to -1?
Well, at the zeros, they wouldn't care about they wouldn't have aversion to inequality anymore because there would be 0, so that effect on utility is becomes 0.
Right. Same goes to alpha of 0, right? If I have
Yeah.
alpha equals 0, then I don't care about other making more money than me. Therefore, I wouldn't feel any disutility in my overall utility. Okay, so what about beta equals -1?
It means you have pleasure in seeing others people's pain.
Yep.
That makes you
So
happy. Yeah. Okay.
yeah, so like you will have this like very sadistic kind of like I guess just enjoying to see other people is like poorer than you, or doing worse off than you, then you gain more utility from that. Okay, that's good. What about alpha equals -1?
You you love billionaires. That's what it means.
Huh? What does it mean?
It means that you care about others people's fortune.
Right. For
That makes
example,
you
if
happy.
your brother or sister like win a lottery or something, you're happy for them, right? You're sincerely happiness like for someone, right? If they're doing better than you. Um, okay. So that's just some outlier beta and alpha. Well, okay. So let's look at the question. So alpha equals to 1. What does that mean? Well, I think we explained already, so we probably don't need to do it again. Okay. Okay, so general case scenario, your alpha is gonna be equals, well, not gonna be equals 1. It's gonna be some coefficient, but in this question, alpha is equals 1, beta equals less than 1. Okay, briefly interpret the utility function. I think we just did, right? Okay, so should we go B? Okay, so here's the case of ultimatum. So can someone tell me what's ultimatum? What's the ultimatum game? Just out of curiosity and fun. No, it's just
Uh, there's 2 players, and one of them is proposer, one of them responder. And
Mhm.
proposer proposes an amount, the responder could accept or reject. Upon acceptance, they get payoffs, and upon rejection, they get nothing.
Okay, so good. So so in this case, I'm gonna draw a tree. So I equals proposer, and J equals to responder. Okay, so in this case, some S amount, right? So propose in some S amount. And then what's the outcome?
Yes and no.
Right. So yes and no. So when it's no, nobody gets money, right?
Yeah.
Okay, just want to make sure. Okay, so you propose it like of some S amount. So you have well, let's say you have $1 and you, well, let's not use $1. You have 100% of something, and then you propose some S amount, and then J will receive S amount, right? That will be the outcome. I'm scared. So quiet. Okay. So how do we set up for this type of question?
It's a 2-node question, so we have to use backwards induction to node 2 and then go to node 1.
Yep, exactly. So we know for sure that if there's some amount of money S, right, then J would definitely choose S over 0, right? So for example, if you have $100, if you give me $1, I should accept that $1, right?
Yes.
Yeah. Oh, okay. I just want to make sure. Like in terms of like we didn't put the whole utility function, like the unfairness or like all that kind of stuff in the equation. I'm just talking about in general. If you offer me $1, I should accept it compared to not, right?
Yeah, in general case.
General case. Yeah. So we know that this is not the case. So we can use backward induction using this as our base. So how will J feel about this? Should I use 2 color? No, 1 color. So J, what's J's utility? J's utility would be equals to the amount of S it's given minus. Okay, let me just write the whole equation. And you guys tell me what to do. Let's just say 8 and then yeah, this is correct. Right? So this is J's utility function. How J feels about the S dollar.
It would depend on how much S would be.
Right. So we know at this case, this is aversion to what? Aversion to what?
Inequality when you are worse off than the other person.
Right. Aversion for other people's fortune. I'm jealous. Okay, so then we don't have anything B, right? Because we know for sure that the proposer is never gonna give more than 1/2. Maybe I should start from there. Should I start from there? Let me just put it down. Okay, so here's the proposer's utility function. Should I start from there? Let me think. Yeah, let me start from there. So this is, let me just use blue pen. This is a proposer. Proposer is giving some money, 1 minus S, minus some alpha, S minus 1 minus S, minus B of 1 minus S, minus S. We know that A is 1, right? So is there ever a scenario where proposer will give more than 1/2 to the proposer? Well, no. Is there a scenario of the Is there a scenario that I will give half to J?
Up to half, but not more than half.
Why not then? Not than half.
Because alpha is greater than beta, so you get more pain from the alpha than the beta, so you try to stay on the alpha side of the equation.
It's true, but it's not comparing to beta. Like alpha and beta, it's not like you can't really compare them. Because in this case, there's only one thing that is matter, right? If I'm giving like, for example, if I'm like giving a whole dollar to the J, I will have a -1 utility, right? Because my alpha is 1. Alpha is 1. This is describing aversion to others' fortune. So I guess every magnitude between I and J, if J is higher than me, I'm gonna feel the pain, right? So for example, if I'm like giving, if I have 0.4, and then my difference between 0.4 and 0.6 is 0.2, right? Any amount more than half, I'll have this utility. Because this is not optimal. We don't know B, right? Like maybe B is like some negative number. I'm like super happy. Well, no, maybe it's not negative. Negative, it's like sadistic, right? Like you're happy to see other people struggle. Yeah. In this case, like this never, like B is never become a thing because this is a max. It's either 0 or max of differences. If I give him more money than half, then my B will just go away. It becomes 0. Because 0.6, 0.4 minus 0.6 is equals to -0.2. And it's not the max. The max is 0. 0 is greater than -0.2. So the whole B will cancel out. So there's no way I will ever give 1/2, more than 1/2 to J. Okay, so we solved that problem. So now we can just erase this and then keep going with J, because J is the most important one. Right. So here, this is a version for others, for others' fortune. Okay. Okay, so what would that number be? Let's just solve this equation. J, in what scenario will accept the number that is offered? Like under what scenario J will accept, will say yes rather than no?
If the share that he receives is greater than his minimum.
It's greater than 0, right?
Yeah.
Yeah. Okay. So because if it's less than 0, then J will just say no, right? It has to be greater than 0. So 0 equals to S minus A, well, 1 minus S minus S. So we have S minus 1 minus S minus S, which equals to S minus 1 minus 2S, which equals to S minus 1 plus 2S equals 0. So we have 1 equals to 3S, and S equals to 1/3. At minimum, I needs to give 1/3 to J in order for J to not choose, to not reject, right? Let's switch the yes and no. Reject. Accept. Right? Does it make sense? What beta cancel out again? Oh, a beta is a version for other people's pain. I don't want to see you in pain. Because you are in pain, I feel worse. Aversion to pain. But in this case, the B is gone because I will never give more than 1/2. Does it make sense? Okay, good. Okay, so now we found the critical point for S min. The minimum amount of money I should give to J in order for J to say, okay, this is fair. Did I lose anyone, or should I keep going? This is a long question. We're gonna be on B for a while. If you have a question, please let me know.
Wait, so we get this critical point, and what is this? So this is the final outcome that the share just has to be greater than 1/3?
No, this is the minimum. Right? We
Yeah,
found the minimum when we found the maximum, right? And there's
Yeah.
one more variable we haven't taken into account in our model, which is the beta from I.
yeah.
Right? So what if what if beta from I, it's like, do we remember what beta stand for? Aversion to other people's pain, right? What if I's beta, it's negative beta? Right? Okay. So what is our beta? So we know that I the S equals 1/2 and S min equals to 1/3. Okay. Okay. Now let's try to find our beta. What is the amount of beta that we will give 1/3? And what is the amount of beta that we will give 1/2 in terms of I? Right. So that's just J. And now we have I. I is the proposer. Right. So for proposer will have 1 minus s minus beta of 1 minus s minus s. Wait, did I do something wrong? Nope, that's correct. So that's our utility function for proposer. So we have our responder already, right? We know their alpha. Assuming that we know their alpha. If alpha equals 1, right? We know their alpha already. And we kind of know beta, but like the beta it's not like beta less than 1, it doesn't mean anything. But we do know alpha. So if we know alpha, then we know how responder will respond. If you are giving less than 1/3 of the share, the responder will reject. Because at responder's point of view, that they will experience negative utility. They will rather you have nothing. Right? So now we're at the proposer side. So let's do backward induction. So we have the accept, but we have to also sorry, guys. Let me just like look at one things. I'm following my notes. But I feel like my notes is explaining B and C instead of B alone. But okay, it's okay. We'll go through it. So let me just like copy down, maybe not copy down. Can I copy down? Let me just move everything down a little bit so I can draw a little bit more. Okay, so that's, how about like, let me just draw a little bit more tree. So this is like some amount of S, and then this is some amount of, let me just not do that. That's on question D. Okay. Let's keep going. I'm like a little bit weirded out by myself. Okay. So now you have this. Okay. What did I do here? Oh, I set 2i equals to each other. Yeah. Okay. So here you can set when the proposer is giving 1/2 and when the proposer is giving 1/3, and then set them equals to each other to see, because they have to have the same beta throughout, that beta must be the same. So you will have 1/2 minus beta of 1/2 minus 1/2 equals to 1/3. Oh, no, that's not 1/3. That's 1 minus 1/3. Minus beta of 1 minus 1/3 minus 1/3. And you'll have, this is 0, you'll have 1/2 equals to 2/3 minus beta of 2/3 minus 1/3. And you will have 2/3 minus 1/3 beta equals 1/2. No, now just algebra. So 6/3 minus 6 to the 4th equals 1/3 beta. And then we'll have negative 1/6 equals to 1/3 beta. And you will have negative beta. Now beta equals to 1/2. So your critical point would be 1/2. At beta equals to 1/2, proposer are indifferent between given amount S or given amount S min. You will have a combination of if beta is less than 1/2 and beta equals 1/2 and beta is greater than 1/2. So this will be indifferent between 1/2 to 1/3. S equals 2. When beta is less than 1/2, that means we're gonna pick 1/3, the bare minimum. If beta is greater than 1/2, we'll give them 1/2. Okay. So let's just recap. So if beta is less than 1/2, proposer will be careless about responders' pain, which is J. So I will be careless about J's pain. It would be determined by the responder's minimum's acceptance of 1/3, right? So does it make sense? If beta equals less than 1/2.
Yeah.
The proposal will offer 1/2. Well, no, will offer 1/3. Because simply that there's just not so many aversion to other people's pain, right? So I simply don't care about your pain. Or I don't care about inequality. Right? I will give you the bare minimum that you think it's fair, so we can make this transaction, so we each can gain from this ultimatum game. But if I care about you, if my beta is greater than 1/2, then I will give you 1/2 and 1/2. Because I think it's fair and I will have maximum utility. But if my beta is equal to 1/2, I'm indifferent between giving you 1/2 or 1/3. I'm most likely to give you 1/3 because I'm indifferent. That's for part B. On the backward induction. So we go from all the way from this point, like comparing responders utility to get S-min. And then we're trying to find out in what scenario would I give out what number of S? Like what is S meant to be? We know it's between 1/3 and 1/2. But under what circumstances it will be 1/3 and 1/2? That's why we need to find the beta. I feel like I'm just like talking about symbols. I should talk like just like a regular person. Okay. Any question on this? Or confusing or stress or anything?
So to to find the beta, what I did was I factored and then gave a scenario analysis, but there's actually a way to find the beta itself using this this equality.
Yes.
Okay,
Like,
that's the
you can find the critical point,
uh-huh.
right? Only the critical point matters because on the critical point, we change our decision, right? If this is above my, well, I mean, if it is, you know, more than 1/2, like my decision is different than if it's less than 1/2, right?
Right, so if S min was a quarter instead of a third, it would still be beta one. Would it still be beta a half, or would it be some other beta? Because the critical point should still be a half, I think.
It might not be.
Okay, that's why it has to be found through
Yeah, because
equality solution.
if you look at this is S-min. The blue is
Mhm.
S-min, right? So if your S-min increase, so if I like my aversion to others fortune, I guess, become less, I guess, you know, if it's less, then I can exploit you more, right? Because you like, and for example, we are playing a game, like I am the proposer. If you have less alpha, I'm gonna give you less money. That's it. Because I know your S-min is gonna be low. Right?
Yeah, that makes sense. Thank you.
Yeah. So like, I mean, if your alpha it's like 100, like I guess if I give you the whole like whole money or whatever, you will still feel like it's not fair. I don't know. I haven't tested this like really edge solution yet. But if you would have like alpha of 100, yeah, I think that will be berserk. Or like bizarre. Really bizarre situation. You will choose to reject every single point, no matter how much I give it to you. Oh, no. Wait, is that true? Is that true? No, it's not true. It's not true. It's not true. It's not true. Yeah. Even if your alpha equals 100, if I give you more than half, you wouldn't reject. because your aversion to other people's fortune would be 0. Right? This is like 100 max of xj minus xi, or 0. Right? If I give you 1/2 and 1/2 already, like your whole alpha is gonna be gone. Yeah. If you have an alpha of 100, then I will be forced to give you 1/2. Because I know your S min is gonna be 1/2. So at that point, it doesn't, my beta doesn't decide anything, because your alpha is so huge that all beta, like S will equals to 1/2, 1/2, 1/2 if B equals to anything. It doesn't, like, if your alpha is big enough, like my beta doesn't matter.
Okay, that makes sense.
All right, sorry, I stuck for here for a while because I want to like explain this a little bit clearly, because C and D is the same thing. We're playing with the same item. Okay, let's go with C. So C, for what value of beta? Oh, I think I just did that. All right, the beta. Okay, we know the beta. We go forth with D. So now the proposer does not know the responder's alpha. So previously we know the responder's alpha. Now we do not know. It's in between 0 or 1 with equal probability. So now we can draw another decision tree just for fun. So here is, this is 1/2. This is 1/2. Probability of J is giving J's alpha equals to 0, right? So we have the case of if it's 1. Our outcome would be 2/3, 1/3. Okay, now this is alpha equals to 1, and this is alpha equals to 0. All right, so you have the two option of accept or reject. So if you reject, it's 0, 0. If you accept, what's the value for accept? If your alpha is 0. So let's go back again. Use this thing. Use responders utility function right here. Maybe I should use pink. It's getting dark. Okay. So in this case, J's utility function will be equals to, if alpha equals 0, So if alpha equals 0, what does it mean?
They don't care about the inequality, adversion for more fortunate.
Right? In other words, means that J is willing to accept anything that he gives. Right?
Right?
Yeah. Okay. So it will be 0, 0. Oh, no, not 0, 0. It will be 1 and 0. I will give you nothing. Because for you, you are indifferent between 0 and 0, right? If your A equals 0. The utility function will look like, oh, I shouldn't erase. J equals to some S amount minus 0, because it has nothing to do with you rich than other person. So your beta has nothing, so it's 0, right? So this is alpha. This is beta. Both 0. Right? But if you use the backward induction, like I will give you 0. So J is 0 equals 0. So it's 0. It's indifferent. Okay, so how can we calculate this probability and the outcome of the automaton game, right? Previously, we found the outcome, which is this blue bunch of things. Yeah, this is the outcome. But now we're trying to find the outcome for I. Well, how much will I propose if there's half and half chance of J's alpha equals 1 and 0. So how do we set it up? So if A equals 0, you'll have 1/2 probability of a utility function of 1 minus beta of 1 minus 0. Right? So this is, oh, yeah, and plus 1/2 of 0 minus beta of 0 minus 0. Right? So this, this is describing this two line. And then 1/2 is from here. If A equals 1, which means 1/2 of oops, 2/3 minus beta of 2/3 minus 1/3, which is the utility function, expected utility function from I, right? Okay, so we keep going. We just need to sum it up. Mhm. So this thing equals 0. And 1 minus beta, so this is 1 minus beta. So this is 1/2 of 1 minus beta equals to 1/2 2/3 of minus 1/3 beta, right? So this is equality. We set a equals to 0 is equals to a equals to 1. That's we're trying to find the equality in which I is indifferent because we still don't know the beta yet, right? Just like previously we set up. Previously we set up that this inequality, right? It's the same thing. We're trying to find the beta in this case. When we can find the beta, we will know that S is equals to 1 if beta equals to some number or like greater or whatever. And S equals, or maybe not 1. It's not 1. It's 1/3. And then S equals to 0 if beta equals to some number, right? That will be the outcome. We're trying to find the equality to find the beta. We already know the outcome. Okay. Still, again, I felt like I'm talking a lot with just formula and functions. Any questions? Do you guys try this by yourself yet? Or no?
Could you repeat a equals to 0 if a equals to 0 part?
Hmm?
Could you repeat the
Purple?
function that you put for a equals to 0?
Oh, we're trying to find
Thank
we're trying to find the equality so we can find beta. All right. So we can find beta. We don't know beta yet. But we know the probability of A. It's 1/2 1 and 1/2 0. Right? So here, this is a 1/2 0 part. If A equals 0. And this is 1/2. Well, this is probability. Prob.
Okay, I got it now. Yeah,
Okay.
makes sense. Okay.
Yeah. We're trying to set them equal. So I is indifferent. We're trying to find that critical point again, in which that I have to make the decision of whether giving 1/3 or giving 0. Yeah. Okay. Let me just quickly go. I don't want to like rush the math. Because the math is like it's not something that's yeah. Like it's I shouldn't simplify. I should just cancel out. Right? 1 minus b equals to 2/3 minus 1/3 b. So minus b plus b, we have 2/3 b equals to 1 minus 2/3. Did I happen to screw up? Let's see. This is positive 1/3 equals to 2/3. I think I screwed up somewhere. Where did I screw up? Oh, shit. Okay. This math is. As you can see, I can't even do simple distribution. Let me just do it. Where is somewhere around? Hmm. Hmm? Alright. There's some problem with it. That's 0. But did I make any math mistake? I can't look through my own work. Oh my god. I made the mistake. I made a mistake. Sorry, guys. See. Scrap this. Scrap this as well. This shouldn't be 1/2. 1/2, it's already here. This is the problem. Because this case, if a equals to 0, Hmm. This is not 1/2. This is not 1/2. This is offering 1/3. And this is offering 0. Okay, am I confusing myself? Okay. Really confusing. Okay. So this is the probability, which is already here. You shouldn't have a probability here. And reason is what? Is that if I have A equals to some number here, a weird question. Hmm. Backward induction from here. We need to do this first. Oh, okay. So this is binary, right? It's either 0 or 1 for alpha. Right? If we know, so if alpha equals to 1, the only case scenario we will have is 2/3 minus beta, 2/3 minus 1/3. This is our only case. But if A equals to 0, we will still have a case that 1/2. No, that's not taking 1/2 into account yet. So if we have 0, we have 1 minus beta, 1 minus 0. And we have another case, which is 0 minus beta of 0 minus 0. Right? Hmm. So what's this case? This is if I propose and I succeed. Success. This is if I propose. I fail. So in this case, this is actually A equals 0. This is A equals to 1. Only when A equals to 1 that J is able to reject my offer. Right? So that's why we should set 2/3 minus beta 2/3 minus 1/3 equals to 1/2 of probability of I succeed on my devious plan and 1/2 probability of me not succeed. Okay. Okay, that makes sense. Okay. It's like stuck for a reason. Okay, does that make sense? Because on top, so here's the 1/3 option. Let's put a yellow. This is yellow. Yellow would be like, imagine if it's 1/2. So 1/2 probability of A equals whatever of me proposing 2/3 minus beta of 2/3 minus 1/3. And then plus 1/2 of 2/3 minus beta of 2/3 minus 1/3. So that's the yellow. Because if I'm offering, so it looks exactly like this tree. We're trying to set that yellow is equals to the pink. We're not saying that I have 1/2 probability of giving J 1/3, right? We're not. If I'm giving 1/3, I'm giving 1/3. It's not half probability. It's only if I want to gamble his alpha. That's why we have the 1/2 probability in the two outcomes when I offer 0. Okay, question? Did I lose anyone? Sorry, I'm making a mistake.
Sorry, what's the interpretation for the last thing that was written? The 1/2, 2/3 minus beta, 2/3 minus 1/3 plus 1/2, 2/3 minus beta, 2/3 minus 1/3.
Think about this as conditioning. Like, if you're conditional on that you were giving 1/3, what's the probability of the results, right? But if I'm conditioning on 1/3, it doesn't matter what alpha that J will have, because J will always accept, because that's a S min, right? But conditional on if I giving J 0, that the whole probability, it needs to add up to 1, right? So it looks like this. Reject condition on 0, and then accept condition on and alpha equals to 0, condition A equals to 1, which this will be equals to the probability of probability of me giving $0. Well, probability of S equals to 0. Right? S equals to 0. Because the probability of S equals to 1/3 is already determined. When S equals to 1/3, it doesn't matter what alpha J will have, because J will always accept, because that's the S min. When I'm giving J $0, I'm gambling on whether or not he is willing to accept or reject. Right? If J has an alpha of 0, then, well, which is 1/2 probability, 1/2 probability, 1/2, right? So there's a 1/2 probability that J will reject, which is if J reject, it will be 0, 0. But if J didn't reject, then it means that A equals 0. I feel like I'm losing people.
So P, if it's S0, that's the gamble that the question's really asking about, because if we did S to the S equals 1/3, we already know that probability, that's 100.
Exactly.
It's guaranteed, but so the whole equation is designed to figure out
beta.
The beta that gets us to the point where they're indifferent between the 1/2 coming from the gamble, the 1/2 gamble.
Gets us to this.
Yeah.
This is the result. Right? This is the result. On what condition I will be given 1/3. On what condition I will be given 0. Depends on my beta. Right? I hope this is clear.
Just one more question. Sorry. Why is the 1/3 being compared to the 0 then?
Because we need to find the beta. Beta is unified.
Right.
Look at the question. It says here. They both.
Oh.
So no matter which line we took, the beta will always be the same. It have to be unanimous throughout this whole space. They both have.
Okay, so if you know the beta that gets us to the 1/3, we know we can use that to get us to the beta that gets us to the 0. Because they have to be equal to each other because they both are the same
Exactly.
in terms of preferences.
Yes.
Okay, that makes sense. Thank you.
Yeah, okay. If you still can't like turn your head around it, try to go through it yourself again after this. And then if you still cannot get your head around it, I don't know if there's any easier way to get the beta. Like in terms of like make it graphically make sense. You'll see. But yeah, I'm happy to help if you guys have any question. I'm just gonna go through this and then get the beta out. Just push through this space. Okay. So in this case, we'll have this equality. And we have 2/3 minus 1/3 beta equals to 1/2 of 1 minus beta. Because this is 0. The whole thing, it's gone. So this case, we have 2/3 minus 1/3 beta equals to 1/2 minus 1/2 beta. 2/3 minus 1/2 equals to negative 1/2 beta plus 1/3 beta. In this case would be 1/6 equals to negative 1/6 beta. So beta equals to negative 1. So at beta equals to negative 1, we know that's the turning point, right? So we have a probably something look like this. So let's say S is the payout, and then we have beta here. Right. So it'll probably be here. This is 0, and then this is like 1/3. Here, this is like beta. Right? Oh, no, negative 1. Yeah, well, I mean, yeah. Okay. In terms of like, how do I know? It's because I did it 2 hours ago, 4 hours ago. Can't remember. The reason I know this graph, it's because I did it. But if you do not know, simply like you can do simple reason, but you can also just plug it in. Right? Because we know that in previous question, we have is it like beta is in between, well, beta equals to 0.5 and 0.5. Like we have like critical point is 0.5, and then there's like a beta and then another beta. This is a beta of good, and this is beta of bad. Right? So if we're a beta of good people, we care about other. If we are beta of bad people, we are disinterested about the inequality. But if we have a negative beta, that means we're happy for other people's inequality. Like we're happy to see other people fail or having less money than us. So in this case, I would say that your critical point, it's definitely, so here it should be like if beta is less is less than -1, and this should be this should be equal. This should be greater than -1. Oh. So how do we interpret this? Is that if you are the person that you enjoy to see other people like suffer, if your beta is actually -1, well, I mean not double negative, but if you're like -1, then you would have this payout of 0. Like you will give 0 to that person. It doesn't though. It matters with the probability. It matters with the probability, right? Because I'm still seeking to make my money, right? But if I'm a good people, like if my beta is greater than -1, obviously it's not that great, but you will give 1/3 because you don't want to risk the chance of you losing the money completely. Yeah. Okay, so that's it for D. I should just stop for asking questions, or are you guys are still energetic to go over question 3?
I would prefer to go over question 3, but if not, that's fine too.
Okay, how about this? Let's take a like maybe a 5-minute break. And we'll go over question 3 because I need to get a coffee. Is that okay? Yeah. Okay. Well, I'll just put this here so you guys can look over it if you want. Wait, I only wrote 2 pages. Okay. Okay, I'm back. Sorry for the long wait. Okay. Let's go over question 3. Question 3, it's like slightly easier. Okay. So question 3. Okay. Any question on question 2? Okay. Question 3. Suppose there are 2 individuals, 1 and 2, in an economy. Each has a show following utility function over income and hours of work. So this is a kind of like something similar to macro. Just write down the utility function, y minus h squared. And then assume the income is based on hourly wage. So income y is equals to WH. So question 8. Solve for each individual's optimum work decision. Okay. So optimum work decision. So what can one to maximize anything? So in this case, it's hours of work. So max h not equals. It's y minus h squared. Okay, which is max of h of wh minus h squared. So du dh set it equal to 0, which is w minus 2h equals 0. W equals to 2h and h equals to 1/2 w. So for A, individual's optimum work decision would be 1/2 w. Okay, bye, Marnie. Anisha. Yeah. Okay, so that's just a regular optimization thing. Okay, let's go B. Now, imagine each individual takes social comparison into account. So the utility function for person 1 is, so you're comparing yourself with everyone else out there. So U1 equals to, let's just like substitute in right away, minus H2 minus alpha of some W H1 plus WH2 over 2, right? So let's kind of briefly stop and kind of like explain this big equation term? Like, what are those? Anyone? Any takes?
Um,
Hmm?
is that some sort of average?
Right? So this, let me just use highlighter. So this is some sort of average, right? You're averaging yourself and other person, right? Imagine this is a country. Like, think about yourself as the United States, and think about Y2 is like some other country, right? Canada, right? Yeah. So assuming though the wage is like market competitive, that we don't have a border, we can feel free to travel. The only things that varies between two of us, it's the hours of work, right? You work your own hour, I work on my own hour, and we're trying to each maximize our utility, right? So this turn explain that some of this utility, some of this utility that we have comparing to the first optimizing utility function, right? There's some this utility of like comparing to well, taking other into account, right? Okay, so let's just briefly optimize this. Oh, we're assuming a equals to 1 in this case. So we just still max of h1 equals to wh equal wh minus h squared minus alpha to some wh1 plus wh2. So we have du dh1 equal to 0, which equals to w minus 2h minus so a equals 1. So it goes away. So we have w over 2. Right? And then we set them equal to 0. So we have 1/2. So w minus w divided by 2 is 1/2 w, and then equals to 2h. H is equals to 1/4 w. Okay. So by adding this social comparison, we come up to a new optimum decision that we're gonna work less hour. I mean, compared to the first one, right? The first one is 1/2 wage. Now we have 1/4 of a wage, assuming wage is the same. Right. Okay. So that's it for 3B. Well, C. So solve for society's optimal level of work. Maximize U1 plus U2. Right. So before, this is all individual. This is individual. So by including social, then we have max of H1, H2 of U1 plus U2. Right. Everybody's utility together, and we're trying to come up with a magical number for H1 and H2. Right. So how can we all maximize our utility? Yeah. Okay. So what would that be? That would be max of WH1 minus H2 minus a WH1 plus WH2. This is actually pretty fun. I miss behavioral. I wish I can retake it again. Plus WH2. So this is the U2. So this is U1. This is U2. WH2 minus H2. Right, let me just put all the thing. Make sure. Alpha of WH1 plus WH2 over 2. Right? So maximize H1 and H2. That's our thingy. So how do we maximize them? We maximize them by du1 plus u2 bracket dh1 set them equal to 0, which equals to, so now it's respect to h1. So here we need to be careful, just like macro. What are we taking derivative of what? It's what? So this is w1, w1. Here's a w1. And then here is another w1. Okay, so we take a equals 1. We have w minus 2h1 minus w over 2 plus minus w over 2. Okay, in this case, we'll have w minus w over 2 minus w over 2 minus 2h1. Okay, everything cancel out. So we have h1 equals 0. Right? Bisymmetric, bisymmetric, that the decision for h2 will always also h2 will be equal to 0. That's their social optimum decision. So it will be better off for everyone to not work, which is great. Yeah. You should look over the paper on how exactly is the mechanic works and how is this applied to the social policy. But for now, I'm just solving the question, not trying to give you intuition. The intuition should be in class. Yeah. Okay. Yeah, that's it. That's it for C. For social optimal level. And there you go. Now we go to D. Intuitively explain the difference between your answer A, B, and C. Explain why tax can make everyone better off relative to unregulated outcome. Okay. So, do you guys want to try to answer D?
Well, the difference is that one has social comparison and one doesn't have social comparison.
C is social optimum. This is social comparison. This is by myself. Okay.
Reduces the amount of hours worked and therefore gets us closer to the social optimum compared to the social comparison.
Right. Something like that. Yeah. If we have like really high tax, then everyone just don't work, I guess. And then everyone is better off by not working. Oh, yeah, you have to support it by some theory. That's how you can get a full mark for D, which I'm gonna leave it to you guys. Yeah, I think that's half correct. Just need to expand a little bit more. Yeah, because you add in taxes. You're adding taxes on the. I guess it also has to do with like what type of tax are you added on? Are you adding like percentage, or are you adding on the wage? Right. Does it work on adding on the wage?
I don't think a wage tax would improve necessarily, because everyone would be taxed with a wage tax, and then we'd be back to where we were.
Yeah. Cool. Okay, that's D. And now, let's move on to E. Unless anyone have a question on ABC. Anyone? Okay. So E. Now consider modifying the social comparison utility function, where A equals 1 over yi, I, which is two people. Like two people have two different social, I guess, some coefficient, right? So A is a coefficient. If a coefficient is made out of your like, oh, how much income you were making. So if you were making a larger amount, then you don't really care about comparing to other, right? So let's look at this thing. 1 over y. One second. You just like compose of W edge of WH1, or let's just put it in. Yeah, so this is a coefficient. So if I work long hour, I would discount this comparison a lot more. But if I work smaller hour, I would discount it less. Yeah, I'm not so sure. Same thing as the previous one. Do some reading and then like maybe interpret it in a better way than I can for now. But we could definitely do F, which is solve. Solve is easier than explain. Continue with a modify function in part E. Assuming W equals to 1. W equals to 1. And solve for each individual's optimum work decision and socially optimal level of work. Okay. So we'll have this whole thing of, so first, individual. What does the individual looks like? So individual will look like, and what M D U 1, what am I doing? So max of H1, and then the equation will be W h1 minus h1 square minus 1 over WH1 coefficient with WH1 plus WH2 over 2. So this is the individual's function. So how do we maximize it? If W equals 1, so we have H1 minus H1 squared minus 1 over H1, H1 plus H2 over 2 minus H1 2 minus 1/2 minus H2 to the H1 to H1. And we're taking derivative of this. So this will be 1 minus 2H1 minus 0 minus respect to H1. So H1 in this case would be 1/2 of 2 H2 over H1. Let me rewrite this. This is equals to H2 1/2 of H1 negative 1. Okay, so taking derivative of that would be 1/2 H2 negative 1 H1 negative 2. Okay, this is correct. Okay, 1 minus 2H1 minus cancel out positive 1/2 H2 and H1 to the negative 2 equals to 0. Okay, now we multiply everything by H1 squared, H1 squared, and then this get canceled out here. We have H1 squared minus 2H1 cube plus 1/2 H2 equals to 0. And H2 equals to H1. In this case, let's take off one H1 would be H1 minus 2H squared plus 1/2 equals to 0. Multiply by 2, 2H1 minus 4H2 plus 1 equals 0. And now we have ABC. And in this case, we can use this negative b plus minus square root of b squared minus 4ac over 2a. And we will find the optimum of H star, H1 star. Okay. Sorry, I'm making too much math mistake. Any question on this? For the individual? Okay, for the social, so 2, social, optimum. Yeah. So this, I'm just gonna write it out, not gonna solve it. This would be max x1, x2 of u1 plus u2. In this case would be max of h1 h2 of h1 minus h1 squared minus 1 over h1 h1 plus h2. Oh, this is so long. And then plus h1 minus, no, h2 minus h2 squared minus 1 over h2 over h1 plus h2 over 2. So maximize this, and then you will have h1 star, which is equals to h2 star. That's the social optimum. And then that's what for F. Any question on F? Okay. For G, intuitively, so still like explain why is individual's optimum work now is higher than optimum part decision in part B. Yep, all the intuition should be in the reading and in the class on Monday. So yeah, just explain. Okay, 4, it's very similar to macro. So it's like multiple period and trying to optimize over multiple period. So it's relatively not too bad. So I think you guys should be able to do all of them by Monday. Yeah, that's it. That's it for me. 2 hours and 44 minutes. That's it. Zach.
Well, thank you.
Okay, no problem. Yeah, if you have a question, you can stay.
Thank you.
Have a good night and good luck on your exams on Thursday.
Thank you. Thank you.